So again, today we're doing a little bit of a review of algebra. I'm going to be talking about some mixtures and solutions today. So a little bit of science to throw in here before we get into the math. A solution, of course, is just a mixture where one substance disappears into the other. We have the solvent, which is the main substance in the mixture. In medicine, generally that solvent is a liquid. And generally that is some sort of a sterilized water. The abbreviation we use for that is generally NS. Now NS can stand for a couple of different things. It stands for normal saline. Normal saline just means it's water that is pH balanced to match the pH of the human body. Also can stand for neutral solution, which means it might be a solution other than water, a liquid other than water that has no medicinal value to the body at all, or it doesn't fit the NS, or it can just be sterilized water. The difference between normal saline and sterilized water is the normal saline is, again, it's just water that's been not only sterile but pH balanced to the human body, where the sterile water might necessarily not be that way. So anyway, that is the salt, the liquid. And for like I said, medicine, we're using that NS. And then there is the medication, we're going to call it a serum in this case, the diluent that gets put into it. And that is our medication. Again, we use that generic term of serum just because this class is not about teaching you the medications themselves, it's about the math behind it. So that material, in this case usually a powder or a liquid medication, gets dissolved into that solvent. The amount of medication is really the important part here. And the amount of medication in a solution, the amount of serum, is always equal to the concentration times the amount of the solution itself, the total solution. So for example, if we have a 30% solution and we have 600 milliliters of it, the amount of medication or serum in that solution a 30% is a concentration of 0.30, or just 0.3, times 600 milliliters. That's going to be 180 milliliters of serum or medication in that solution. So if we mix 600 milliliters of a 23% solution and 300 milliliters of a 35% solution, what concentration will we have? Or what will be the percent of the solution? So what we're combining here, we're combining 23% with 35% to get a resulting percent that we're trying to find. Well, the amount of serum that goes into the mixture has to be the amount that comes out. So the amount of serum between the 23 and 35% has to equal the amount of serum in the final product. The volume also has to, the total volume going in has to equal the total volume coming out. So let's take a look at that. The amount of serum or amount of medication in the 23% is 0.23 times 600 milliliters. We're going to leave the milliliters off just for ease of calculation here. The amount of medication or serum in the 35% is 0.35 times 300 milliliters. Now we don't know the percent or the concentration of the final product. That's going to be X. But we do know the volume. What's the volume of that final solution going to be? We have 600 milliliters and 300 milliliters. That's going to give us a total of 900 milliliters. So now we're going to do a little bit of calculation here. 0.23 times 600 is going to give us, what is that, 138? Looks right to me. 0.35 times 300 is 105. Equals, x times 900 is just 900x. So now we're going to add. 138 plus 105 is 243 equals 900x. And we should divide by 900. Giving us 0.27 equals x, or 27% solution. Simple enough, right? However, normally we are not randomly mixing two solutions to see what we get. What we are normally doing is mixing two solutions to get a desired percent. So let's take a look at how that would work. Let's say that we have on hand 48% and 54%. We need a 52% solution. So the question is, how much of the 54% do we mix with 170 milliliters of the 48% to get that desired 52% solution? So again, we're mixing 48% here with 54% to get a result that's going to be 52%. So the amount of medication or amount of serum in the 48% is 0.48 times, do we have a volume? Yeah, 170 milliliters. Plus 54% is a concentration of 0.54. Do we have its volume? No, that's what we're looking for, is the volume of the 54%. So that's going to be our x. And that equals, well, now we have the concentration of the finished product is going to be 52%. So that's 0.52. The amount is, just like before, it's going to be found by adding the amount of the other two ingredients. So I have 170 plus x is just going to be 170 plus x. And now we're going to simplify our equation and solve. 0.48 times 170 gives 81.6. 0.54 times x is just 0.54x. Over here, we have the parentheses, so we're going to have to distribute the 0.52. 0.52 times 170, 88.4. 0.52 times x is a positive 0.52x. So now we've simplified whatever we can on each side. Before we can solve, we notice there's an x on each side of the equation. We need to get rid of one. The smaller one is 0.52, so let's get rid of that. We subtract 0.52x, so that's gone over there. We just have 88.4. We must subtract 0.52x from the other side. We can only take it away from the 0.54x. That leaves us 0.02x. It's positive, so we put a plus. And we have the 81.6. Now it's in a simple equation. The decimals make it look ugly, but it's still our simple two-step equation. We're going to subtract 81.6. 0.02x equals 6.8. And we're going to divide by 0.02. X equals 340. And that, of course, is milliliters because we were dealing with milliliters up here. So it's 340 milliliters of the 54%. Let's do another example. So let's say on hand we have 27% and 42%. We want to know, we need 33%. We want to know how much (42%) do we need to mix with 360 milliliters of the 27% to get the desired 33%. So once again, 27% combined with 42% gives us, we're going to use that to get our desired 33%. The amount of medication in the 27% is 0.27. We have a volume of 360 milliliters. Medication in the 42%, concentration of 0.42. The volume there is what we're looking for. How much is what we're looking for. That's going to give us our final concentration is 0.33 and the final volume, like before we add together the other two ingredients, so 360 plus X. Again, if you didn't catch it, we're just adding this number and that number. The volume of the 27% plus the volume of the 42% gives us the total volume of the 33%. Now we simplify and solve. 0.27 times 360 is 97.2 plus 0.42x. 0.33 times 360. 118.8 plus 0.33 times x is 0.33x. And now we have to get rid of one of the x's because we have an x on each side. We'll subtract the smaller one, which is 0.33x. We still got the 97.2. 0.42 minus 0.33 is 0.09x. And over here, all we have left is the 118.8. Now again, it's just in two-step form. We're going to subtract the 97.2. So 0.09x equals 21.6. And we divide by 0.09. Gives us 240. So since that was in milliliters, that's 240 milliliters as well. Any questions so far? Okay. Our next problem. Let's say that we have 64% solution. And we need 55%. How much NS, sterile water, to mix with also 240 milliliters of the 64% to get the 55%. This one tends to stump people just because they think there's a piece missing here. What we're mixing here is we're mixing the 64% with sterile water, NS, which is 0%, to get a 55% solution. So the 64% is 240 milliliters, so 0.64 times 240. The sterile water is 0%. That's 0.00 times the amount is going to be x, because that's the amount we're looking for. Now, we don't even need to write that in. We know that 0 times x is going to be 0. It's going to cancel out. But I write it in there because when we do the amount of the 55%, that'll be 0.55. We need to remember that's 240 plus x is that total amount. So now we have 0.64 times 240, 153.6. 0 times x is just 0, so we don't even need that. 0.55 times 240 is 132. 0.55 times x is 0.55x. Now to solve, we're going to subtract 132. So it's 21.6 equals 0.55x. And divide by 0.55. And we get 39.27 milliliters is x. So the only tricky part to that is realizing that sterile water is 0% and putting it into our formulas. Now another side of this, we might have, say we have 24% solution and 32% solution. We need 720 milliliters of 26% solution. So the question now is how much each do we need of the 24 and 32%? Well, this one's a little bit trickier. So we're mixing the 24% with the 32% to get 26%. We don't know the amount of the 24% or of the 32%. The only amount we actually have here is the amount that we need of the 26%. So that concentration of 0.26 times 720 milliliters. Now for the 24% and the 32%, we need to figure out amounts. If I just pick one of them to be x, let's pick the amount of the 32% to be x. The amount of the other, since we have a total volume of 720 milliliters, will be 720 minus x. So the amount of medication in the 24% will be 0.24 times 720 minus x. Plus, the amount in the 32% is 0.32 times x. And now we can solve. So we're going to do the 0.24 times 720. 172.8. And also the 0.24 times negative x is negative 0.24x. Positive 0.32x equals 0.26 times 720. 187.2. Now we can do some combining quick before we start to solve. We have the 172.8 won't change. Negative 0.24 and a positive 0.32 is a positive 0.08x equals 187.2. And now we can subtract 172.8. .08x equals, there's that 13.4, I believe. And then we divide by 0.08. So x equals 14.4 divided by 0.08. It's 180. milliliters is x, but now we got to go back and we got to remember to answer the question here. It wanted to know how much of each. Well, x was the amount of the 32%. So that is 180 milliliters. So 180 milliliters of the 32%. We also need to know how much of the 27%, which was 720 minus x. So 720 minus 180 will be 540. So 540 milliliters of the 24%. Any questions? Similar to that, let's look at a cooling system that requires, so we need 60% antifreeze. If I wanted to be technical, we'd say 60% ethylene glycol in the system. It currently tests currently it is at 45%. So the question is, how much pure antifreeze to add to 1,200 milliliters of the 45% to get to the 60%. So this is similar to the one we had before where we're diluting it with just the sterile water, or NS. Here we have 45%. To that we're adding pure antifreeze, which would be 100%. So instead of 0%, we're dealing with 100% this time. And we're going to a result that's 60%. We know the amount of the 45% is 1,200 milliliters. So it's 0.45 times 1,200 plus the amount of the 100%. Well, 100% will be just 1.00. We're looking for how much of the pure antifreeze, so that is x, equals 60%, 0.6 or 0.60. And that's going to be 1,200 plus x is that amount. So now 0.45 times 12 is 540. 1 times x is just x. 0.6 times 1,200 is 720. 0.6 times x is 0.6x. Now I have an x on each side. I'm going to get rid of the smaller one, which is 0.6. I subtract 0.6x, leaving me with 0.4x. We still have the 540, so 540 plus 0.4x equals 720. And we will solve by subtracting 540. .4x equals 180. And then dividing by 0.4. To get that x equals 450 milliliters. So we would add 450 milliliters of pure ethylene glycol, or pure antifreeze, to that system to get it up to 60%. Well, let's look at one a little bit different. Let's say that we have, let's say we have a 4,800 milliliter system that tests at 46%. For our current working conditions, we need 54%. So the question is, how much do we need to remove? And add pure antifreeze in this case to reach the 54%. So this one's a little trickier. We have the 46%. We're adding 100%, running pure antifreeze again, and going to a 54%. Well, we're asking how much of the pure antifreeze do we need to add, or do we need to remove and put in? Well, the amount that we remove is going to equal the amount we put in. So we're going to let the amount of the 100% or pure antifreeze be X. The amount of 54% we're going to have is going to be 4,800 milliliters. We have to fill the system up. So really the tricky part here is how much of the 46% are we really going to have? Well, we're going to have the full 4,800 milliliters take away or minus the X milliliters that we remove and replace. So now our formula, we have 46%, so 0.46 times 4,800 minus X plus 100%, or just 1 X. That's going to equal 0.54 times 4,800. So now, 0.46 times 4,800. $22.08. 0.46 times negative X is a negative 0.46. X plus 1X equals 0.54 times 4,800. 2592. Now we're going to combine. Negative 0.46x plus positive 1x is a 0.54x. So 2208 equals 2208 plus 0.54x equals 2592. And then we're going to subtract 2208. So 0.54x equals 384. So now we're going to divide by 0.54. So 384 divided by 0.54, 711.11 milliliters. So we would remove 711.11 milliliters from that system and replace it with pure ethylene glycol. Now when we have these problems like these, some of these last couple here, where we know the final amount, there is another way we could approach it. So let me just put an example up here, and I'll do it this way, and then I'll show you the other way we can approach it. So here we have 72% and 84% solutions. Bless you. Let's say we need 78% solution. And we're going to need 480 milliliters of it. So I want to know how much of each of the 72 and 84%. So we're going to combine 72% with 84% to get to a 78%. We don't know how much of each. Now you'll notice we know that all we know is that we're going to have 480 milliliters of the 78% when we're done. We don't know how much of the 72 or 84%. Now in the last one, I chose x to be the larger percent. And there's a very good reason for that, because then I have a positive coefficient on the x. So if I let x be the amount of the 84%, the 72% will be 480 minus x. So we're going to have 0.72 times 480 minus x plus 0.84x equals 0.78 times 480. And we'll solve from here. 0.72 times 480. 345.6. 0.72 times negative x is a negative 0.72x. Well, that's just going to stay a positive 0.84x. 0.78 times 480. 374.4. And now we're going to solve. We're going to combine negative 0.72 and positive 0.84 is a positive 0.12x. We'll still have the 345.6 equals 374.4. And we're going to subtract 345.6. So 0.12x equals, what is this going to be? 28.8, I believe. That looks right. And we're going to divide by 0.12. Get x equals 240. So now again, we have to go back and make sure we know what x was. X was the amount of 84%. So we need 240 milliliters of 84%. And 480 minus 24, 240 milliliters of 72%. So we were able to solve that with a single equation. Now most of you, I'm guessing, have gone far enough in algebra that you've seen a system of equations. So another way that this could have been handled, let's just map it out again. We have our 72% mixing with our 84%. We get 78%, and we're going to get 480 milliliters of that. And rather than defining the variables the way we did, we could have just said, hey, x is the amount of 72%, and y is the amount of the 84%. So we end up with 0.72x plus 0.84y equals 0.78 times 480. Now we have two variables here, and we can't solve a single equation with two variables, so we need a second equation. And there is a second relationship between the x and the y. X plus y has to equal 480 milliliters total. From this, then, we could go ahead and solve a system of equations. A couple of different methods. We could do substitution, elimination or addition, depending on what your books call it. We could do matrices. We're going to go ahead and we're going to do substitution. To do that, I'm going to solve this second equation here for x. I'm going to subtract y to give us x equals 480 minus y. So now I'm going to replace x in my equation up here with 480 minus y. So 0.72 times 480 minus y plus 0.84y equals 0.78 times 480. Now at this point, what you'll notice is this equation here, except for the fact that it's in the y variable instead of the x variable, is exactly the same as the equation I created up here. So all I've really done up here is by reasoning out that this must be 480 minus x, is I have taken out a couple of steps in the system of equations, but it really is a system of equations for solving that. We've just managed to use some common sense to avoid doing it. Okay, well, we have about 7 or 8 minutes left here, but I think that's enough for one day. I do recommend that you do several of these in your homework. We're getting into the stuff now where you can't skip over it anymore. Usually on our second test, these are the problems that people struggle with the most, are these mixture problems. So in your book, page 53 through 54, 1 through 15, the odds. If you did all 8 of those, you'd be pretty well prepared for them. So I will end it there, give you the last 6 or 7 minutes to work if you want. Otherwise, we'll see you on Friday.